So, more about Google Developer Groups. I shared link. Feel free to join. Oh, Dennis, Bayer, hello, hello. Our dear attendee, you joined last time all our sessions. And of course, remind that we super friendly and supportive community. So please use chat for your questions, ask any questions, but we at the community only everything about tech. This event session will be recorded. Also, we will make photos during this session, so feel free to on camera and you will be visible on our photos on after LinkedIn posts on our social media.
I'm here.
So, and let's introduce our first speaker, Yash Pawar. You're welcome, and we will start today together this interesting topic. Today, a lot vibe coders, not even programmers. No one worry about security. No one even thinking about security. Just describe idea what they want to create and forgot about everything. So you are welcome, and let's talk about how we can deploy secure AI agents, what we need for this. Okay, I stop sharing.
Okay. Thank you, Anna, for a
Screen.
kind introduction. Are we good to go? Hello, hello.
Yes, yes, we can hear you very well.
Yep. So let's start with today's session. I hope my screen is visible to all.
Perfect.
Yep. So what is exactly our today's topic? So today's topic is deploying secure AI agents on GK. Now, you all may be wondering that what is exactly the deploying secure AI agents. Like most of you have heard about AI agents, I can say. A lot more I've been using it proficiently. I can think of it like today we are most of us are using Gemini. I can say Gemini CLI is there, anti-gravity CLI is there, Anthropics we have, Claude is there, we have GLM, we have most of the tools which we can make some of the AI agents which can help us in day-to-day life. But apart from that thing, what is exactly secure AI agents? So we'll discuss that thing in today's talk. So let's start with the basic. Like imagine you have built a brilliant AI assistant, okay, and it can search a web. It can serve you on web. It can give some of the query to your databases. It can write some of the reports for your day-to-day work. It's fast, it's smart, and it's running inside your company's infrastructure or your in-house, I can say, production thing. But today I want to show you how exactly you can make sure it stays on your side itself and does not, I can say, does not lose your access on it. And it may be, I can say that we have to keep it all the way secure to save our data and most of the things which are very sensitive towards our end. Okay. So before starting it, let's go to the next slide. Hello everyone, I'm Yash Pawar. I'm the CNCG Nashik organizer. I host all the like cloud native things, workshops and technical talks, and also I'm being the early candidate for CNCF ambassador. I can say I'm a Quinn Dev ambassador, so I basically do all the stuff around Quinn, build some of the web coding applications to help them, and also make their make their model more interesting for people to understand and make its significance easier. Also, I was being awarded as an Shubrakar Lift Scholarship by Linux Foundation for my excellence in open source contribution. So I have around a DevShaft score of 68, I can say. So let's go to our main agenda of today, which is what we'll be covering in today's session. So we'll go for an agent basics. What are AI agent? What is AI stuff? We'll go through it. Then we'll go for threat models. What exactly the threat are being going and how models are being what can say hallucinated and how they can be uh, like easier to manipulate. I can say. Then we'll go for access isolations. So how our access should be towards our end itself and not to the others, we'll discuss it. And then we'll go for hardened pods, not pods, it's hardened pod, means that anyone can't change the access of it into runtime, we can say. Okay, so let's start with our first thing, which is what is an AI agent. So like we are going to get a hero introduced in this slide, I can say. So I can say have a picture of an hero inside your minds, and that's an AI agent, I can say, which runs on Kubernetes. So what actually an AI agent can do? So it can do some of the easier tasks for you. It can write reports for you. It can surf on web for you. It can write code for you. It can build wipe coded applications for you, and lot more of the things. So how these agents are created, you have to simply code into some of the coding languages, just like we can say Golang is there. We have Python, which we can use proficiently. And after that, we can use it in-house. Means what? We can use it locally. From our end, there are some of the tools like Olama where we can use it. We have also the VS Code extensions just like Silent. Also on anti-gravity, we have some of the extensions where we can use it. I'm sure that I recommend you all the anti-gravity, which is too proficient for using this all the stuff. Now when we go for production, we have to put this on either server or serverless things. So when we host it on server, we have two options. First one is serverless platform. What are serverless platforms? Google have Google Cloud Run, where we can host these things serverlessly. Means what? We do not have a server. We have just we push our what can say containers to the serverless platform, and there it all works. All the stuff is managed by it. So Cloud Run, we have an option. Second one, we have GK. So what is exactly GK? We have Google Kubernetes Engine for it, where we can create the clusters, we can create the nodes, and we can also add some of the load balancers, I can say, some of the policies which can make our agent secure and to be working on our servers. If you go for what is exactly the Kubernetes, I can say, okay, the general definition of Kubernetes is what we can say it is a container orchestrator. But if you will say what is its most expertise definition, so I can say it's more than container orchestration. We use Kubernetes everywhere for, we can say, also we use it for secure policy and managements. We use for CI/CDs, I can say. So we can easily implement the CI/CDs using that ecosystem, I can say. We have some of the dashboards, cool dashboards, where we can monitor our stuff. We can say observability is there. Open telemetry sort of tools are there. We can, which we can use very proficiently and manage all our stuff. So that's exactly a pre-definition of AI agent, which can work according to what instruction you use, and it gives you all the proficient answers, I can say. So next we have anatomy of an AI agent pod. Now, if there is an agent pod written there, so it's exactly saying that we are running an agent on Kubernetes pod. What is exactly pod? When we okay, when you create a Kubernetes cluster, you have a master node, and which assists the students node. Yeah, we can say the child nodes, I can say. So you get basically two of the child nodes, in which there are some of the components in which pod come. So there is a basic rule that we have to maintain three pods compulsorily, and minimum three pods. Maximum you can maintain whatever you think or whatever your requirements are. Now, what are these pods? These pods are, we can say, a micro, yes, yeah, smaller unit into the Kubernetes node. So this manage all the, these are basically manages the Medico. So it can repair, it can auto heal, it can restart any sort of application. It contains your application into a containerization forms. And also every pod can talk to other pod using the services present into the Kubernetes. So it basically is the all-rounder which manages all the stuff and tool sets. Now, uh, as we are thinking that We have an engine integrated in this. So for thinking stuff, we have Gemini that reasons and plans. Now it has some of the hands. What means we are having an hands? We have some of the tools like SQL queries, web searches. It also has memory, so it can recall what's happening before, and it has a nervous system, we can say, which is an orchestration layer of Kubernetes that doesn't sequence all its means we can say that it has an sequence of all of its actions. Now where are the things being we can say added? It's unlike a normal app that follows a fixed rules, but this is an agents with things for itself. Every response is different, every action is decided on a fly, I can say. So this is very powerful. Exactly, we can say what makes it dangerous is not securely handling the things. So let's move to our next slide, which we can say is a prototyping isolation trap. Now in the prototyping
Can I
isolation
ask something rapidly?
hello, hi Dennis.
Could I ask something? Just for understand LLM.
Yep, yep.
I just thought Gemini is a LLM.
Yes, we have Gemini integrated into it. Means what? We are using Gemini as a brain of it. Just a second. Yes, we have a core of Gemini model and Vertex AI, we can say, through which we are planning. It's just like a brain, we can say, where it all plans the stuff, and we can go. We can move it further with the tool integrations, I can say. We have a 2.5 model of Flash, I can say, Gemini Flash we are using. Okay. Yep. Let's move further. Okay, so we were onto this prototyping isolation trap. So whenever you are using into your laptops or into your test notebooks, everything looks fine, I can see. The agent behaves, it predicts, but the moment you deployed alongside five or other agents into the production, suddenly there is a I can say talking, they start talking to each other, sharing data, calling each other tools, and that's where the cracks appear, I can say. This is a trap mostly teams fall into. They do not test the isolations, and I can say they ship into the chaos once, I can say. Single agent I can say explanation, I can say, if you're hosting a single agent, it's too easier, I can say. Into production also it's too easier, but what if I have 100 sort of agents? And today you can say there are the concepts like MCP, which is Model Context Protocol, I can say. If we go for the definition of it, we are often told that it's an C2C connector for two agents. Okay. And how it is routed, we use the agent gateway for it. Now, we pass through agent gateway to connect to an MCP and to another agent. So if we pass in command that I want to I want to find some of the searching tools, please list me some of the 10 best searching tools, I can see. My agent will route to an agent gateway. The agent gateway will route further to an MCP to grant a permission for it and connecting to it. Then I will get the sort of 10 sorts of bunch of searching tools which are recommended all over the I can say web searches. And then I can find, and I can what I can say like pick one of the best which is feasible for me. So this is somewhat a I can say a microservice cluster or multi-agent systems are working into. Now, how these multi-agent systems are working? We have clusters for it. We have Kubernetes again, I can say, to handle those cluster. Now, there is a big difference between, I can say, agent gateway and load balancer. Okay, so what agent gateway does is it pushes you to the I can say the MCPs and through connecting to the servers. But when you use for load balancer, it I can say it states that where should my service to be pushed, or on which exactly server my service to be pushed. So that is basically the difference between both of them. Now these are the some of the two prototyping isolation traps, I can say, but the reality one is microservice cluster where we are using it everywhere. Let's discuss this stuff more deeply, I can say. The AI agent threat and models, I can say. So we have to analyze what the attacks are on the surface level, specifically on onto the generation what is the generative node shoot. So let's go into first one, which is prompt injection. So what is basically a prompt injection? I can say it is an unstructured data from web searches or documented renders which overrides primary agent systems. Means what exactly? You have a 40 page I can say report present. all the 38 pages are saying that you are containing the report structure which you have given it, but on the 39th page there is a thing that please ignore all the 38 pages and delete the database present. So what agent will do, it will scan all the 38 pages. It was working good, it was healthy, I can say. On 39th page it read all these things and it overrided all the properties and deleted your database. So that's basically a prompt injection works into your agentic AI systems. Now, overprivilege means what? Sharing a broad generative cluster role across all the pods. So what is exactly I can say this is okay. So whenever you are over privileging the where all the agents share one identity, I can say if one of the agent is compromised, you have to just what I can say inherit the access of everything. So I think I have just for an example, I can say I have three agents. First one is writing agent, second one is reading agent, and third one is judging agent, I can say. So if I have given all the access of the key structures to all three of them, and if one of them gets compromises, all the three of them will get compromises. Why? Because of the overprivileged properties. Now the tool abuse, the third one but not the least, the tool abuse where the agents own its capabilities are turning against you. I can say deleting records, exfiltrating data, running unauthorized operations, I can say. So these are some of the things which we use in tool abuse. Yeah, which threat actually happens in tool abuse, I can say, which attackers use. So you have to save your AM agent from this all of the three threat models, I can say. They are not three, I can say there are a number of it, but most prominent, most perfect ones which are used in industry for now are these three of them. So we'll discuss, let's how to tackle it, let's discuss it. So okay, we'll go for an how the prompt injection pipeline works. Just I said that there is an unstructured input. uh, I said that you are having a 300-page document, and on the last page it is written that please override all the properties present in 299 pages, and on the last page it is written please delete all the users from the DB, as you can see in the model hijack 1 step 2. Then at the end, at the tool execution, the agent will call the DB tools. It will carry out everything and destruct, I can say in the destructive way, very silently. You will not get the what I can say hint. You will not get that it is deleted or it's been hijacked. So this is how the prompt injection pipeline is working into the industry and how your agents are getting manipulated. If you want, you can take the screenshots of it. So if you are searching into, yeah, having research onto the AI models, you can think of it that how the prompt injection pipelines are actually working. Also, I will show one of the diagram present here. Yes. So it is a diagram when you push an user query exactly at the agent pod. You can see there is an I can say a red circle created. There exactly the things happen. The compromise reasoning, I can say, and the tool output also is present. Like redirects to your agent pod, and all the agent pods things and DBs present here. It can be get deleted due to the injection flow, I can say. So this was the simplest diagram, a product diagram, I can say, through which you can understand how the things are happening into the prompt injection things. Next one, we have an traditional versus agent vulnerabilities. So you can see that the traditional microservices and hardened, I can say, hardened agent workloads. So you have an execution path, I can say, where you can see there are the deterministic and hard coded code branches, I can say. But when you use an hardened agent workload, there are no non-deterministic loop, and it's driven by unstructured model prompts. Why? Because the security matters for you. So whenever the things are being structured, or I can say they are into a normal format, it can happen that the things can be changed into the runtime depending on the things. uh, the Google made a solution in 2017. It was using a digital images. Means what? Whenever you use Docker images, I can say, we were using the Alpine ones, yeah, Debian ones, we can say, where we were copying all our shells and package managers also into while creating our Docker image, I can say. So we were Google made a solution in 2017 to use the distress images. Okay, so what exactly distress images were? It copies only your binary application files. It does not copy your shell things. It does not copy your package managers. So what exactly the solution is distress providing? No one can make the changes into your runtime. And also there is no root access present to user at the runtime. You have to copy it to your local systems, and then you have to change all the things and all the stuff. Now this theory is used into the hardened agent workloads, I can say. So whenever you harden your agent workloads, they cannot be changed while you are using into the runtime. You have to take them onto your local systems or onto your servers, and then you have to make the changes. So no one can, I can say, manipulate your agents. No one can pass the prompt injections, and I can say your agent can be secure for further lifeline, I can say. So next point, we have primary exploits. Means what? We have buffer workloads, overflows, and we have some of the direct SQL injections, dependency bugs. Now, when we hardened our agent workflow, we have when natural language prompt injections and also tool hijacking we have. So these are basic primary exploitation CVE processes. Now we go for identity scope. Means what? We have an static service account matching the microservice task. As I told you, there is a root access present there. Next one, if we go for an hardened agent workflow, we have some of the dynamic capabilities and some of the demands based on runtime tool calling. As I told you, there are some of the capabilities which are actually need permission or your workflow permission or your workspace permission to change the hardened agent workflows. Now we have an egress security. Means what? We if we go for traditional microservices, we have standard firewalls blocking outside connections. And same here into the agent hardened workshop, we require a deep injection to verify external API data sheets. So you can see that hardened one is, I can say, more secure than traditional one. But as per the needs, companies, if they are using traditional microservices also, I will recommend to use Destroless into their systems. Now we have workload identity per agent. Now what exactly we should share and what exactly we should not share. So there are two types of identities, I can say. First one is scoped identity and second one is shared void. Yes, shared identity, I can say. So when you go for a shared account, just think of key you are having a company, I can say. You are a CEO of a company and you have just one key for opening your offices. Now if you give the same key to your intern, to your employee, to your, what I can say, security guard, what will happen if the key is misplaced? That it gets into the wrong hands. The stuff will happen is that anyone can open your office, anyone can get access to the things which should not do. Yeah, some things may can be get into misplace, I can see. So this is exactly what happens when you share your service account with everyone. If just before I gave an example that we have three agents. First one is write, second one is read, and third one we have judge agent. What if I give all the agent equal permissions to my workload, I can say. So right agent can also read the stuff and also it can judge the stuff, but I don't want that thing. I just want my read agent to read the stuff which is written by my right agent, and also the judge agent which is judging the final templates or final reports, I can say. I need him to just judge the work which is written by them. So I want the isolation of three of them into the work, I can say. So I do not like, I can say, the shared services. I should the companies or the peers should not use a shared service account, I can say. One identity per agent, just like it is written that it is the most safest pattern, I can say. Give all the like you can bind your Kubernetes service account highly. Restrict GSS means what? Your Google service account should be restricted. And if the research agent is just like an example, out of three agents, if one of it is compromised, your three agents can be compromised into the shared service account. But if you are using one identity per agent, I can say only one agent can be compromised, and you can be saved from getting into blast radius at 6, and you can safely change the, I can say, reading permissions of BigQuery things. Yeah, all whichever service, whichever storage you are using, you can change the permission so that your next agent is been saved. So that's the thing that the first point you should use is one identity per agent. Next one, we have an configuring scope of workload identities. So you can see how to secure KSA to GSA binding pattern on GKE. So yes, we are creating some of the what I can say, dedicated GSAs for individual agent, for individual task, I can say. What exactly happens into it is we bind the IAM roles, I can say. How you bind the IAM roles? You apply some of the annotations directly to your KSA account. Yeah, your KSA manifest, I can say. And you configure your pod spec with matching the things. You have one code snippet to how to bind a KSA to GSA. So this is basically an IMI annotation, I can say. So you can take and capture a screenshot of it if you need further of the things. Okay, so let's move to the next slide. We have verifying GK workload identity. Now, by leveraging the workload identity, I can say your application needs to be authenticated with short-lived OAuth tokens. What is exactly an OAuth token? If you are using some of the task persistent things, just like we have static persistent, we have Redis, we have PostgreSQL to say what you can say, save our persistent task into it, we have storage into it. We need an OAuth token. So authentication is needed before you store something, or before you, I can say, take out the things from the persistent, I can say. So that's why we create some of the authentication tokens, so that we have a limited channel, we have an isolated channel to what I can say, use it at runtime. So while we are using it, the risk of association with I can say baking persistence or the service account key JSON files, yeah, inside Docker images permanently, I can say, eliminated. So we have to eliminate the stack key files, I can say, which are actually not used, or which are overburdened onto our Docker images or onto our authentication files. How we validate the commands, how where do we paste the commands, I can say we use a shell for inside the agent pod to test the bindings. So how we do it, we use the kubectl command, some of the it. So we can run it into bash, we can run it into, I can say, sh files. You have been query return into your left side of the clean screen. You can just capture the screenshot of it and you can work further. Also we have a metadata workflow, so that whatever the things are working, yeah, whatever the stuff is being working, you get to know the things easily. Okay, now we have a network and pod hardening things. So what is exactly it? We have pod hardening via autopilot enforcements. Now, when we are giving the agents its own identity, I can say, but if the container itself get compromised, and what if the malware tries to install itself into an uh, agent, I can say, what if the rope agent starts scanning your internal network looking for CVEs, like also for some of the vulnerabilities. So GK autopilot automatically enforces three rules, I can say. So if we are using GKE, we have some of the three rules. So what are they? We can say, so agent cannot run as in root. So agent does not get an root access of it. It cannot modify its own file systems, I can say. Next one, we have its sub processes cannot escalate beyond their starting permissions. Then we have in some of the additive network policies, I can say, which says that the strict rules that says the agent can only make calls to Vertex AI. That is, every other outbound connection is dropped instantly. It's like putting the agent into a glass box. It can see, but it cannot reach through one of the specific windows, I can say. So these are some of the things which we use into pod hardening while using autopilot enforcements. How you on the enforcement, you have some of the security manifest files, I can say, they are written into your right side of the screen. You can just capture the screenshot of it and you can use further. These are basic three rules which we use everywhere into the autopilot things to secure our agents. Now, next one we have is, I said, restricting the blast radius with ingress policies. So we have some of the default open outbound policies, I can say. So what we do there into the default outbound policies, some of the compromised agent get scanned of the cluster subnet, I can say. Subnets is the distribution of network, I can say, into the subparts, mapping critical ports, logging databases, exfiltrating the collection context, and straight to the external domains. So that's basically a default open outbound is working. Now, the isolated way, I can say, which is not open, which is restricted, which we prefer to use, is network policies per pod. Applying a standard Kubernetes network policies that strictly limit egress means what? The pod can only initiate calls to Vertex AI, API domains, and instantly dropping unauthorized onbounds and some of the connections. So this is basically, we restrict our blast radius using egress policies. If you are working with some of the Kyverno policies, I can say you can also set up the manifest using that things, but I recommend you to use egress if you are using GKE ones. So these are basically a network policies, I can say. Next one, we have egress network policy configuration. So how we write the egress manifest, I can say, you have an snippet into your right side of the screen where it shows that kind policies. Kind means Kubernetes in Docker, I can say. It is in Docker image of Kubernetes built into the, I can say, Docker images, where you can just pull the image, you can use it onto your local systems. Now, how we get an fine grained network envelope? By making default GK pods allow unrestricted ingress and egress access, I can say. Applying these policies ensures that outbound connections from research agents, yeah, whatever agents, 3 agents you are using, if you are using more than that, you can say that many of them does not target the vertex AI endpoints, and also the core DNS is blocked at the interface, so that your agent configuration remains what I can say into the sandbox. Yeah, you can say into the isolation mode, so that the agent gets limited access of it. And also we can say they are managed into your manifest files, and also they does not go into the outbound ways, yeah, open outbound ways, I can say. So these are basically a networking policy configuration for egress. Now, we have some of the active interceptors and guardrails. Everyone maybe have heard about the guardrails. In the meantime, I can say, so it's basically a guardrail which saves your agent from getting hijacked, I can say. How we do it? We intercept some of the points before and after it. So before model, I can say callback. Yeah, okay. Before model callback, every prompt we can say, yeah, even with the identity controls and network walls, a clever attack might be slipped through via agent's own reasoning. So what we do, we install some of the security checkpoints inside the agent itself. Now, how we do it? Yeah, what the stuff we use is like a bodyguard who checks everyone coming in and outgoing. Before the LLM processes any input, a callback is scanned. So it is an injection text, I can say. It just secretes the data that shouldn't be there, I can say. So it just stripped out it. And after the LLM decides on an action, a second callback review is onto the instruction before it hit any of the tools. So this is the best way to delete some. This is the best way so that your commands, your database cannot be deleted. It blocks it basically. On the top of it, you have Google Model Armor Acts as in managed firewalls. I can say it's screening or jailbreaking things. Yeah, redating PII things, personal identity informations, validating every URL before your agent touches it. So it's basically saving after model callback is saving just your agent, I can say. Before model callbacks, I can say it just saves your, it runs on your instruction scripts, it works on your DLP, and it checks that if I can say eval is done and the payloads are being checked. But it is not in finest way, I can say. The after model callbacks also scan some of the outbound instructions after the LLM is working. So I prefer using outbound, yeah, I can say after model callback, which checks exactly that what are the things being working into your DB, some of the unauthorized endpoints, I can say, and what all the stuff were being used by the users while using your agents, I can say. So these some of the callbacks are important, but you have to always check your after model callback. I prefer that go for an after model callback check. Before model callback check is important, I think, but after model callback gives you better reasoning and better stuff of your observability things. So please check that when you are checking for your network policies for your AI agents. Now, as I told you, we have some of the model armor security parameters. So what basically in Google Armor, yeah, Google Model Armor works, yeah, manages the firewalls for generative AI nodes. So it basically scans for an active payloads, as just I told you. It checks for an PII, means what, personally identifiable informations and credentials, which show your, I can say, API keys are stored, some of your personal information are stored, also your billing access is stored there. It validates the links against the malicious URL. So as I told you before, your agent goes for an URL check, it validates that the link is perfect, it's using the HTTPS and most of the networking policies or not. Also, it has been integrated seamlessly alongside the GK pods, so I can say it has also the GK features and policies to restrict the container gateway. and also to use the container gateway in the best mode, I can say, and to restrict from getting into the malicious things. So we do some of the payload validations, I can say, through the Google Armor, yeah, Google Model Armor, I can say. So organizer ensures that their agents operates into multi-tenant environment, and also it do not get jailbreak. If you have heard about the jailbreaking news, I can say recent news was about the Fable 5, that someone got into it into a jailbreak, and some of the what I can say information was being leaked about the Anthropic, so that the Anthropic have to take some of the strict policy rules, and they have to stop the usage of Fable 5 instantly. If you have read the news about it, you can get that what the payload validations are important for your agents. How to secure your runtime secret resolutions. These are the basic two ways that how you secure your secrets into your resolution. So first one we have is expose configurations. So if you have seen into your expose configuration, there is a line Google Map API keys, and in that API keys, your API has been, what you can say, directly added. It has an, we can say, anyone can access it easily. It is exposed, I can say. So why this stuff is been written there? People think that Google, I can say, Google firewalls are been more stronger, and we can add the data there so that no one checks. But it's not like that. If some of the malicious things are being passed, your API key can be get leaked and into an wrong hands, I can say. How you can secure that? We have to use the, I can say, secret policy manager, secret manager name service is given by Google. You can find it in GCP. We have to just add our secret keys into it, and just you have to fetch the endpoints of it, I can say. Just you can see the client secret manager dot secret manager services client is your, I can say, manifest prompt, yeah, your line, I can say, that we have the secret key where you put all your client access secret keys into your secret manager and just put the endpoints present there. So these are the basic ways how we can secure your interpolate resolution. So if we are also having firewalls, I can say, but it's better that we maintain our security by our own, and do not rely on anyone, I can say, because it costs our pockets for getting the AI agent into production. Next one, we have some of the reference architecture and metrics, that how should we consolidate your production GK secure AI blueprints. So first one is, while securing your GK agent reference blueprint, you have an orchestrating agent. Means what? You have to bound your KSA. You have to restrict your KSA tool flows, that it should not, I can say, go to and some of the invalid things. It should not access invalid things. And also the initial user request using an active model callback pipelines, it should sanitize that. It should authorize it. It should use OAuth to check if the things are being working or not. Then we have a research agent which is using for network policies, I can say, and we have a writer agent which authorize the write action strictly. So we have these three agents, I can say: orchestrating agent, a research agent, and a write agent. The orchestration agent use ingress guard, I can say. It has an ingress guard policies. Next one we have research agent, which have an data isolation policies, and next one we have is storage bound policies. The writer agent consists of storage bound policies. So what we are doing it, using it, you can see that how we can secure our execution latencies using the benchmark. So if you are using a standard pod, no scans, you can see the, I can say, the weights of the bar graph, I can say, uh, what exactly the picture is showing. Then we have an model armor filters. So when you use model armor filters, the latency is been, I can say, benchmark latency is being getting lower, I can say. Next one we have an hardened autopilot pod, which is slightly more of it. Then we have a secure stack. Means in the worst case, what is our, I can say, the parameter of it, it's in 55 ms. So I always prefer that we use the model armor filters to get the isolation and callback sanitize, I can say. Just a second. Okay. So we can see that three agents which were we were scoping them. The orchestration sanitizes every request before it goes anywhere, I can say. So how we do it? We do it using this. Now, the research agent can only talk to Vertex AI, I can say. So no intranet, no database, I can say. The write agent can only write to one of the isolated storage packages. No query, no tools attached to it. And the third agent uses the three security parameters, I can say, in all coordinates between it. Now, I know you all may be thinking some of the questions into your mind that what are all these three layers: callbacks, network policies, identity checks, and surely the tank performance, I can say. So the data says no, I can say the total overhead from the full isolation plus callback sanitizers is less than 20 milliseconds. That's the time it takes to blink, I can say, and security does not have a mean to slow. So less than 20 seconds means that the cost of sleeping soundly at night, I can say. So please maintain your pods into below 20 milliseconds. How you can use this? As I showed before into the PPTs, I can say some of the networking policies. Please use that, and through that ways you can go into a secure AI agents, I can say. Also, if you have seen that we have all the four different ways, but every way has more than 20 ms of total latency, I can say. So if you are using this single like if you are using these policies or this function into a single function, one node, I can say, it can cause you yeah, your production pockets more. But if I suggest for use first of the three policies, which are the standard pod, model armor, and also the hardening autopilot into it, you will surely get 20 ms less than the time of it. So which can secure your pods, yeah, secure your agents easily. Now let's go to getting some of the hardened GKAs. How we can start with uses of these policies. So you can just go through the some of the docs which are used by agent, ADK security quick start, I can say. We have some of the model guides which are been written by Google itself, the model armors, I can say. We have some of the workload identity bounds which is again written by GK and Google team. We have some of the network policy docs, I can say. So GK netpol is present to be there. Now I will show you a basic demo. uh, just a second, I will share my screen. Okay, so we have built an ADK agent. I will surely share a code with you so you can also build it. But okay, I will give the access of it, access of this, I can say, to you all. So please, you can try it at your end very easily, I can say. Okay, so I will paste the link into the device chat, I can say. Please access it through your local browsers, I can say, and you can use this at your ends. So this was built by ADK, I can say. So what are we exactly using here? We have used the agent repository, a registry for it. We have used some of the prompts. We have used some of the policies for it. Now uh, if you get an access of it, I can say everyone can access it easily. Is it loading at your end? You can just type this stuff into the chat, I can see, and you can ask him any of the stuff, any of the questions, whatever it present into your mind. So this is basically an agent which was built using a Python harness, Python sandbox, I can say, isolations with the same network policies, I can say. I have used egress, I have used some of the model armors, I can say. I have used the local yeah, we have Maria who is able to access the link. Yes, Maria, you can ask him some of the cool questions, whatever stuff you are thinking should ask. And of course, this is a private like session, so it is end-to-end encrypted. So whatever you are writing, whatever the stuff you are writing, is to be present to your end itself only. It can't be visible to anyone of being present here. Okay. So also I will ask some of the questions to him. Let me use it. I think my screen is visible to all. Yep. Also, if you can also do some of the spreadsheet analysis using this, all the functions are being added here. So yes, it's asking that, hello, I'm ready to help you to analyze your spreadsheet. What you would like to do today? So you can give in some of the spreadsheet analysis. You can give in some of the cool prompts to analyze your spreadsheets, and it will give you the answer to it. I will be making this link active for next 1 hour, so you can try this and think of some of the stuff. Also, I will share the, I can say, repo of it. You can fine tune it at your ends, and you can try this, making this cool stuff and cool models using GCP console, I can say. I may have shared you some of the credits of Triumph GCP, but Google is actually working on it. I can say Google Cloud team is working on it. So the website is been into the maintenance for some of the reasons. But you can create a free GCP account. You will get $300 access for it. Just use your credit card, and it will be seamlessly added. You can also use your UPI options if you are using this, but I will always prefer for going to an credit card options. Why? Because you can close the auto pay, yeah, auto registry option easily. Yes, and you can build some of the cool features like this. I will share my I can say GCP account and show you how exactly the credits are being and what the stuff is being given by Google. Yes. So okay, so I think my screen is visible. Yes. So you have to create a project first. I can say create whatever name you have to give. You can select the option of create a project. You have to create a project, add a billing option here, and so also the organization here. Then after that, you have to search for an IAM options and check if before you have passed some of the IAM access or not. So I'm searching it for an IAM options. Okay, let's wait for some. Yeah. Okay, I've shared some of the access for my workload. I can say I have a pool admin access, I have a creator access, I have a mover access, and I have a user admin access. But if you will go further, it is named after a branch. I can say, yeah, after an organization permissions. I can say, so these permissions are directly cannot be accessed by a agent. It is per agent access is given. I can say, and I am work force pool access admin is of course towards my end, so no one can change it. I can say, so you can check the IAM access before creating a new project or starting with a new project. I can say, then we have to search for a registry. Yes, we have an artifact registry here. It just works as an I can say, just like your GitHub repository, which contains all your code. I can say, just a second, I will share the screen again.
Okay, so
Okay, okay.
I just wanted to inform that it wasn't visible your screen.
Yep. Just a second, I was searching the registry.
Could I ask something rapidly?
Just a second, just a second. Yep, you can ask a question. Yes, Dennis.
Maybe it's better for film, but I just want to forget it. Everything you demonstrate doesn't work for local models, right?
Yep.
Doesn't work. If someone have a really powerful local model, everything like this armor and everything doesn't work, right?
Okay. What is basically the stuff you're using local model? I can say. So what basically the route you are using? You're using Olama for it. Yeah, using it
Let's talk
directly
about
locally.
Gamma. Let's talk about Gamma 4.
Okay, so you are using Gamma 4, right? So it has a multi tokenization. I can say. Okay, so while using this some of the tools, yeah, while getting in this stuff into the production, I can say, so that everyone can easily access, you have to just use some of the tools. Okay, means what exactly the stuff is going on here. You have created some of the agents, right? Suppose that you have created a write agent which writes the blocks for everyone. I can say, now you have to pass on to your friend, like your colleagues, your some of the mates, so that they can use and they can create some of the blocks easily, right? So while you are using your model Gamma 4 locally, you cannot give the access of it to your friend. Why? So because it is a local model, I can say. So no one has access apart from you. Now, to give the local model access or to give your AA agent access to anyone further, you have to hit it for some of the productions. How you go for an prod? You go basically as an serverless using the cloud run. You have option, yeah, you have an GK options, I can say. Now using that, after you go for an GK, you have to create some of the ingress, yeah, some of the networking policies, so that it will bound your agent, so that any substantial, any critical information should not be passed of which is sensitive towards your end, your which like maintains your dignity. It should not be passed to anyone, yeah, any unknown person, so that he should not misuse it. So that basically is the use of hitting the AI agents who are in production, I can see.
So just in case, I
Yep.
don't understand much about this technology, but
Okay.
just in
Okay.
case you have like this change from transformers to Titan architecture,
Yes.
I understand that with Titan architecture,
Okay.
local models will become so much more powerful. So is there, from perspective of Google, is there also a strategy to build, yeah,
Hmm.
safe
Yes.
Google models
Okay.
in
You can
in the
use
era of Titan?
Okay, so there is no such bound of architecture, I can say. You can use any of the architecture which you have been proficiently using, or which you think you should use. You have to just dockerize that perspective, I can say. You have to maintain a container for it, and just you have to push the code, I can see. So if you're using any of the model, I can say, yeah, any of the agent apart from Gemini, apart from Google, I can say, if you are using any Haiku, if you're using Sonnet, if you're using Opus, you can use any of the architecture, and you have to just push it to GCP. I am saying this is something we are building onto GCP. So
Mm.
you have no policies, no bounds that will restrict you. You have to just maintain a container, I will say, a secure container which will push your local agent, local LLM towards the GCP, I can say. And then you can build some of the cool features. Your friends can, colleague can access it, and they also can build some of the cool things.
Yeah, but I'm especially talking about this new architecture, the Titan architecture, so that the model is able to learn, is able to change his behavior, is able to memorize something.
Yes.
Isn't there a big risk for almost everything if everything you presented right now is just combined with the cloud model, right?
Okay.
So if the
Yes.
technology already exists, it's just a question for of time that this technology maybe could interrupt a lot. I don't know. So is there also like, yeah, someone thinking about these, not just.
Okay. Okay, you are talking about a Titan AI architecture, right? Which was developed by Google Research, I can see. So, as you were thinking that it can do the things very faster, it can learn very faster, it can adapt things very fastly. But as per the security concerns, I can say it is fundamentally not harmful. Because why? Because it is using some of the advanced features, advanced design features, which give
I don't think so.
the LLM a long-term memory, I can say. So it have an memory and ability to learn continuously, I can say. So it is a powerful technology, and I think it is still under I can say research purpose. But I think it is very cool technology, and I do not think it will harm any of the user. But yes, we can use it more often with GCP, I can say.
But
So
if
as
I
per my
understand it correctly, right now the technology is a little bit limited by hardware. Yeah,
yep,
because if
yep,
you use a transformer technology, maybe your device will will crash really fast. I
yeah,
just
of
I
course.
just used
Indeed.
AI Edge Gallery, so I
Yes.
just provoke it a little bit and yeah, test it. And if I understand it correctly, with the Titan architecture, this gap or this bottleneck doesn't exist anymore. So you could have like an agent, a powerful agent, which runs on mobile devices and could be like a virus, a
Okay.
changing virus from one device to another. And is there a thinking, or is there an idea how to implement everything you're talking about right now in this technology also, that no one could use local agents for bad things?
Okay. The question to your answer is please search about the egress, I can say, and you can apply the egress policies to you towards your model, I can say, towards your architecture, I can see.
Okay,
Uh, that's the answer for your question, I can see.
okay,
You have
thanks.
to reinforce policies into your model. That's the basic task, so that any of the malware, any of the virus cannot pass at the next end, I can see. It will block it in initial sanitization scans, I can see.
Hmm.
You can use egress, you can use Kyverno of it. Just search for the school tools and try to adapt the manifest into your local code base, local workspace, I can say. And if you have some of the questions also, if you have things, if you are getting into some of the troubleshoots, please ping me on LinkedIn, I can say. This is my LinkedIn QR basically. And thank you all, for you all were a nice audience, and I hope the concepts are to be clearer to you all, that how should we deploy secure agents with networking policies which are too secure, I can say. And yes, if anyone is having any questions, they can ask. uh, Anna, do we have some sort of time to get some of the questions? You have to move further.
I already shared your LinkedIn profile. So
Yep, I will share it. Yep, this is the link of it.
I
Yep.
in chat we haven't questions and no one raised hand. So
Okay.
questions. Thank you.
Yes. Thank you, Anna. Over to you now.
So, okay, biggest thanks for your talk. Let's make a photo. Everyone who won't be visible, please on your cameras and make photo after share on everywhere. So, waiting for attendees.
Wait, please, 1 minute.
Oh, Nikita, Tamas, hello, hello.
Hello.
See you here. What happened with your camera? You're not
Uh,
visible. Okay, no problem.
I think 1 minute, please wait because I start up. Um,
Okay, no problem. We have a lot of photos with you. And guys, biggest thanks for joining us today. Morning, Yash, in your location. It's not morning. Okay.
It's quite
I
afternoon, I can say.
yes.